So what are real numbers? Marshall?
A number that can be put on a graph.
Okay, a number that can be put on a graph. That's very good. On a number line. You can graph it on a number line. What are the two types of real numbers that we've dealt with in this chapter? One of them starts with the letter R, and the other one starts with the letter I. Please get these. Okay, let's go. Olivia, give me one of them. Irrational. And the other one, Day?
Rational.
Rational. Those are the two types. So we're going to talk about properties of those type of numbers. Okay. Does anyone know, if you're looking on page 50, look at those properties. See that column that says properties? Can you guys just look through it and see if anything looks semi-familiar? Page 50, do you have your book? Maybe share with Ethan for now. Marshall, do those look somewhat familiar? Not all of them have to be known, but do they look like you've seen them before? Okay, at least 3 of them. Okay. The first property is called the closure property. I'm not going to require you to know that. This is all the closure property means. You ready? If I add 2 real numbers together, do you know what kind of number I'm going to get from that addition? A real number. If I multiply 2 real numbers, do you know what kind of number I'm going to get? A real number. That's all it's saying. That it's closed for the real numbers, adding and subtracting. So I'm not going to go through that. You're not required. But the first one I do want to know is the commutative. Commutative property. Now, there's a commutative property of addition and there's a commutative property of multiplication. But they're the same, it's the same type of property. So commutative property, commutative of addition. Let's start with that one. Looking at the commutative property of addition, does anyone know what that might be? Like, kind of looking at, I think Marshall knows it. You can look at it, like, what is that? A plus B equals B plus A. I don't know what that means. Olivia might know. Morse?
You can switch it around.
Okay, I'm going to say the key word for commutative property, and you can put it right underneath it, is order. The order of adding, the order of multiplying can change, and you still get the same sum. All right, so the commutative property of addition, here we have A plus B equals B plus A. Is that true? Okay, that's not, I hope that's not like, wait, what? If you're like, I don't get it with all those letters you're talking about, can you give me some numbers? Give me 2 numbers to add, Kate. Give me 2 numbers to add. Oh, wait. Something I can write quickly. Sorry? Thank you. 10 plus 20 is also known as 20 plus 10. Yes, be shocked at that, right? Okay. That's the commutative property of addition. All right. What do you think the commutative property, so I'm going to do it, it's the commutative of multiplication. What do you think that is? All right, go ahead.
7 times 8 equals 8 times 7.
All right, A times B is equal to B times A. That's how you say it algebraically. Therefore, any 2 numbers that are multiplied together can be switched around. But can you switch around 3 numbers being multiplied together?
Yes.
You can?
Yes. If they're
All right, give me 3 single-digit numbers. Eden?
9 and 8.
And another one.
And
Single-digit. Thank you.
dang it. 4.
All right, 4. Okay, 9 times 8 times 4. So you would normally order of operations says left to right. But can I rewrite that as 8 times 4 times 9? Am I allowed to do that? Is that the same thing? Now, can I ask why anyone would even, why would that even matter? Like, why don't you just do that and be fine with it? Why do you want to switch it up like that? Yes, Sam?
So it's less complicated at the start because it's small together.
Sometimes you have numbers that are easier to multiply first. Like some of you may prefer, I really like 9 times 8. It's easy to do, which is what? 72, okay. But some of you are like, wait, what? I know 8 times 4 is 32. And then you multiply that by 9, or you multiply 72 by 4. Same answer. That's good. And I'll show you some examples of why it's really, really good. Okay, that's the commutative property. What's the key word I want you to get with commutative property? Order. Order. Second one, the associative property. What does the word association mean, or associate? Anyone know what those? I'm going to abbreviate prop of. Agree. I mean, yeah, you can have a little bit of agreement there. Usually you have agreement, but you can have disagreement in an association. But what does it mean to associate? Like I say, Day and Ryan associate with each other. What does that mean? They talk, they kind of hang out. Can I say this? They group together.
Whoa.
That's the key word. Grouping. I'll put grouping or groupings. Associative property of addition or of multiplication. The groupings can change. This is similar to commutative, but it's not the same. That's why we have another property for it. Here's what it is in addition. It's kind of hard to write. Please write it down with me. It's A plus, parenthesis, B plus C. So, order of operations, what would you have to work out first? You have to do the parentheses. You have to add B plus C first, then add A, right? But, because of the associative property, if I'm adding all these numbers anyway, I don't have to only associate B plus C. Instead, I'm going to associate A plus B and then add C. Why would anyone do that? I'll give you examples why someone would want to do that. Okay, guys, did the order of the add-ins change? Ready? A, then B, then C. A, then B, then C. Did the order change? No. What did change?
The grouping.
The grouping. That's different. The order did not, you didn't get B plus A plus C. You just changed the grouping. Now, can I tell you this right now? Some of you are going to say, you know what? I know the associative property. Whenever I see parentheses, it's got to be associative property. Wrong. That is not correct. So please don't think just because there's parentheses, it's associative property. All right, someone give me 3 single or 2-digit numbers, not 3-digit or beyond. Okay. Yes. Yes, Danny?
So 32.
You can say 3. I know.
26.
Okay. Just give them to me. I'm going to think about them.
26, 32, 18.
Okay. 26, 18, 26, and what was the other one?
32.
32. Okay, great. This is actually a good set of numbers. Okay. I rearranged it just because I want to show you a point. Okay. In this problem right here, if you're trying to simplify it, why don't you do 26 plus 32 first? Right? And actually, oh man, I didn't mean to write it like this, right? Because I'm going to apply 2 properties. Just do it like this. I know if you have a pencil, this should have been a problem. Okay, this is what I wanted. And trust me, problems are laid out where you could do associative property and commutative. That's nice. Okay, but anyway, you would have to do 32 plus 26, right? Okay, that's 58. And then you have to do 58 plus 18, right? That's not bad. You guys can do that. Just write it out. You can do it in your head. But what if I did this? What if I grouped together 18 plus 32? Why is 18 plus 32 a little bit easier to group together? Anybody know? Raise your hand. I know 2 boys know. 1 girl, 2 girls, 3 boys. I'm going to do this math. Violet, why is this a little bit easier to do? Yeah, does anyone know what 18 plus 32 is? 50. That's a nice number. What's 50 plus 26? 76. That's the same thing as this one, but I grouped them differently, and it's easier to see. So associative property of addition. All right, we're going to look at the associative property of, so that means I'm not going to rewrite associative property right here, of multiplication. It's the same thing, guys. Except instead of adding, what are you doing? Multiplying. Yes, sir?
Is it possible to group together 18 and 26?
Yeah, so if I did that, if I grouped together these two, I would have switched the order. Maybe I switched these two together, and I would have grouped differently. So I would have done associative and commutative, and we can do that. You're allowed to do that. But in your homework, guys, this is what they're going to have you do. Ready, Marshall? They're going to give you this statement right here. They're going to give you this right here. And they're going to say which property is being applied. So you could say all of them, but that's not true. It's one of them that's best telling me, or best showing on this problem. What's the property that's best being applied here? You have one of two options, commutative or associative. Associative, right? Did the order change? No, the order of the numbers is the same. It's the groupings. So that's what you're going to do in your homework, whoever asked. I think Alec. Okay. All right. I'm just going to give you multiplication. I'm just going to give you like this. A times B times C. Does anyone know how I would rewrite it using the associative property? So this is a good thing to do too. How would I rewrite it? Well, first write it the first time. And then Ben, how would I rewrite this using the the associative property of multiplication?
A times B times C.
Okay, I'm still going to do A times B times C. But where did the grouping symbols go?
Between A and B.
Between A and B. Just like that. So did the order change? No, but what did change? The grouping. Did you get that down? All right. Any questions on the associative property? How many of you would say these are kind of like duh statements? Like, yeah, duh, that would work. That's okay. They are. They should be duh. And if they're not, they will become duh.
You will become.
Because on the homework, I expect 100% accuracy. Okay, the next one. Identity. Oh, I like these. These identity properties are like my favorite. Identity prop of, we'll look at addition first, and then we'll do the identity property of multiplication. All right, identity. The key word I want you to get is identity. That's what I want you to get. Okay. What do I mean by that? Okay, when you have a number and you add a certain number to it, you're going to keep the identity. Okay, so here's identity property. A plus something equals A. Raise your hand if you know what would fit in that blank. A plus something would equal A. A plus something would equal A. Let's go with Carly. It would seem like B, but there's a specific number. There's only one number that would fit in this one to make it accurate. A plus what would be A? It's like, that's a tricky question. Yes, Alex?
0.
A plus 0, isn't it?
Yeah.
Right? And so technically, Carly, if you said B equaled 0, I would have taken it. But yeah, A plus 0 equals A. Man, that's deep. That's so deep. How many of you remember your speed drills where you're doing addition? So this was a long time ago. And remember how you had to do like 1 plus 5, 10 plus 2, and you just had to do like 100 problems and see how fast you could do it? My favorite problems were something plus 0. Because you're just like, I know that one. Even when you didn't know a lot of the other ones. I know that one. And some people, remember how you would sometimes skip problems because you didn't know those? But the ones you knew were something plus 0 or 0 plus something. Easy, right? Identity property. So give me a number, guys. How about this? Give me an irrational number. IRRATIONAL. Irrational number. Give me any irrational number. Don't give me the decimal version of it.
Why?
Okay, Olivia?
42.
Don't give me the decimal version of it. So are you trying to give me like point?
No.
Or all you have to do that 42 is do this. Right? Watch my.
Square root.
Okay, the square root of 42. Okay, ready? Is that a real number? Okay, ready? I want you to do this math fact as quickly as you can.
Wow.
You may begin. Yeah, go ahead. Call it out.
I have no idea. Square.
That's for any real number. The square root of 42 plus 0 is equal to the square root of 42. Guys, you might be thinking, Mr. A, yeah, I get your illustration with the math facts. I get it was easy. Yes, I understood it. I still understand it. Guys, you use this in pre-calc and calculus. This little fact right here. You use it. And either you can use it and understand it or kind of be like, I don't know what I did. I just kind of did something. I hope it was right. No, it's there and it's right. Okay, there's also the identity property of multiplication. But when you multiply a number by 0, do you keep its identity? No. Well, give me a number, Danny.
3.
3. Ready, guys? Oh, I know what the identity property of multiplication is. 3 times 0. Because that equals...
0.
Wait, that changed 3. But what number times A is going to get me A? What number times A is going to get me A?
1.
1. Remember my 2 favorite numbers, guys? I love them. You do too. You love them so much. It's kind of like, okay, this is going to get really sappy, okay? Because you guys are middle schoolers. I get it. I'm older, barely.
Barely.
I remember my dad, when I was in middle school and high school, he used to say this as a joke, but he would say, I don't know you, but I love you. He would say that. I'm like, Dad, that's not cool. Something else I used to call it. I'm like, how does it even make sense? He doesn't know me, but he loves me? Huh? Come on. Okay. You didn't know this, maybe. You didn't know this and that was so important, but you're going to love it. And you're going to love it even if you forgot that, you're going to be like, I like this. And you will. Guys, you know how I change a fraction to have a common denominator with another fraction? What do I multiply it by? Do you remember? I always multiply it by. You're like, but you didn't give us the numbers. I didn't have to. You always multiply it by 1. Don't you do like 2 over 2 or 10 over 10 or 7 over 7? That's the identity property. I hate the identity property. No, you don't. I don't need the identity property. Yes, you do. I can't stand it. Yeah, you can. You do it all the time, and you love it. And I appreciate it. You don't know it, but you love it. Okay. Give me a number, Ryan. Give me another rational number that's not a square root. Ooh. And not a decimal. Ooh. That's not possible, is it? You're like asking me for pizza without toppings. Or pie without... Yeah, ice cream. Or like any other circular object out there that has a certain calculation, like 3 or 1 or 4 or...
1.
Mr. A's favorite food is pizza. Pie. Oh, she got it. It's pie. Pi times 1 equals what?
Pineapple.
Thank you, Ryan. Yes, ma'am.
That's really big food.
I love pizza. And I should stop eating it because I love it so much. Okay, next one is going to be called the inverse property of addition. We'll start with that one. Another one that you love.
This one is the most dumb.
Is the most what?
Dumb.
Is the most dumb. Okay.
I will turn you into dough.
Okay. Here's the inverse property of addition. Fill in this statement here. Okay, A plus something equals 0. What is that something? Raise your hand. You're like, what? We don't even have what A is. Yeah. You don't need to. You just need to know.
Negative A?
Yeah, wait. A plus negative A? Oh, wait. No, I don't get it. Day, give me a number.
12.
12. All right, ready, guys? If A is 12, what's the opposite of A? Right? And what's 12 plus negative 12? 0. Yay, you just gave us a fun fact that we all knew and didn't really care about, right?
Yes.
God, Hannah, if you were really to understand these properties, you're going to make math easier. And I bestow this knowledge on you. Now it's easier. It really is. Solving equations, inequalities, graphs, fractions, decimals, dividing those type of numbers, multiplying them, it makes it all easier if you get this. If you don't get it, it's like, huh? Okay, which is hard. Yes, ma'am.
Wait, if you just bestowed the knowledge to Hannah, nobody else has.
Hannah may now bestow later during break to whoever she wills. Whomever she wills. Okay, guys. I want to kind of clarify something because a lot of people get this confused. Don't erase this like I did. But A does not have to be a positive number. It could be a negative number and it still fits. So CT, give me a negative 2-digit number.
Oh, come on.
You're welcome.
Negative 99.
Okay, negative 99, awesome. Before he keeps going. Okay, if A is negative 99, you're like, wait, that doesn't work, right? What is the opposite of negative 99? Yeah, positive 99. And what's negative 99 plus 99?
999.
Yeah, it's 0. That's what I was wanting to say. Yes, sir?
Is 9 your least favorite number?
9 my least favorite? I don't know. No, I don't have a least favorite number. They're all equal in my heart. Okay. All right, let's look at the inverse property of multiplication. This is a trick question, and I want to see who's thinking about this. All right, the inverse property of addition is any number plus its opposite is going to be 0, right? Take 12 plus negative 12, 0. Great. If I did that with multiplication, it wouldn't work, but I could always get a certain answer. So here's what I'm going to say. What's any number times its opposite? Times its opposite. It's not 0. Because remember, just think in your head, what are some numbers and what are the opposites? What do I get when I multiply? This is a thinking question. Aiden, what do you think? Yeah, go ahead.
You have negative 12 times 12. It's equal to whatever 12 times 12 is, but negative.
Okay, good. He got it. Ready, guys? Any number times its opposite. You don't have. That's not the property. I'm just trying to see if you guys are really thinking. Any number times its opposite is going to be a negative answer, and it's going to be that number squared. Is that true? Well, 8 times negative 8, negative 64. That's not. Oh, 8 squared is 64, isn't it? Yeah. That's just for fun. Some of you were thinking, some of you are like, huh? And that's okay. All right, let's look at the inverse property of multiplication, though. A number times something equals 1. You guys know what that number is? The book has it, by the way, so that's nice. A number times something equals 1. Okay? Say it again. Not 1. I thought you were going to say 1. Something more. Morris? 1 over A. Huh? Let me make this clearer on the A. A times 1 over A equals 1. No, I don't know about that one. That was weird. Okay, hold on. All right, write this down. If you didn't write this down, it's not good. Shh. So listen, there's a little bit of talking here, a little bit of noise making here. Again, you're not helping me out because I'm like, what's that noise? Like, what's going on? Wait, what was that? So it distracts the teacher, but it also distracts your neighbor. That's not loving. So we're not going to do that. And by the way, I'm teaching my kids the same thing. Mommy and daddy are talking. you need to stay quiet and ask after we're done talking. Same thing here. And when my son's talking, I don't just interrupt him. As they're saying, Daddy, you want me to tell you about, stop talking, I gotta say something. I don't want to do that to him because I love him, I respect him. Same with me. You see what just happened there? That's okay, I want you to know what just happened there. Okay, anyway. I got a number here. Let's, remember CT, what we just said?
Yeah.
All right, Alec, give me a number, just any number. Nothing too big.
1,
Other than 1, because that's too easy.
2.
2. All right, guys, 2 times 1 over 2 equals what? Okay, any number times its reciprocal. That's what we're talking about. Reciprocals. Right? Let's take it a little bit further. What is what's the reciprocal of 3/4? Okay, so 3/4 times its reciprocal gives me what? 1. Sorry guys, there's something going on here, and I'm about to assign homework to this group more than the other. So I'm giving you a warning to help you out, because I don't want to do that. Any number times its reciprocal is going to give me 1. And that's very important. By the way, I just gave Algebra 1 a test, Algebra 1 Honors a test, and they needed to know that. Some of them forgot it and messed them up. So if you can remember that, it'll help you out. It really will. Okay, that's the inverse properties of addition and multiplication. By the way, you know how this is called the reciprocal? These are called reciprocals of each other. Do you know what these guys are called compared to each other? They're not reciprocals. They're actually called, yeah, I heard it, opposites. So I'll put opposites there. That's a key word for that, opposites. A number plus its opposite is going to be 0, which is good. It helps. All right, last property. This is the place where people start, they're okay with this. Yeah, I get that. Yeah, I've seen that before. But then we get to this property, like, what? Okay. The distributive property. I am trying to convince you guys, little by little, that algebra is easier than arithmetic. And I'm still at that, and I haven't accomplished it for a lot of you. Some of you believe me, which is awesome, but some of you are like, you're healthily skeptical. That means you're skeptical, and it's natural, and it's okay. But people will fight me all the time. Distributive property, that's a dumb property. We don't need it. Okay, you're going to have to use it. And again, guess what I just tested Algebra 1 guys on? Distributive property, that was part of it. Some of them used it, got the problem right. And it was a hard little equation to get, they got it. Some of them forgot about the distributive property. I'm like, ooh, that answer is not right. And they'll be able to see it too. Okay, this property is written in a couple ways. Okay, if you have a number, A, being multiplied by a sum, B, for example, B plus C. Okay, do you guys notice this is the only property today that has in its example adding and multiplying? Do you guys see? Look at your other problems. Is there any equation where you had adding and adding and multiplying at the same time? Or is there any equation there? No, that's just adding, just multiplying, just multiplying, just multiplying. Okay, this is the only one where you get both of them at the same time. Okay, so that's different. By the way, you know what it also has? Parentheses. So do parentheses always tell you associative property? No, because what could it also be? Distributive. So be careful with that. All right. Normally, what would you do in this problem? You would add B plus C inside the parentheses and then multiply that by A, right? That's normally what you do. And normally, you should do that. But you can also distribute. So instead of doing B plus C first, then multiplying, you're going to multiply A by B and then add to that A times C. And I'm going to put a little equal sign Actually, let me write it so it's not super confusing. Write it over here. A times B plus A times C. So you're going to multiply twice. This problem had you multiply once, right? And so why would I want to multiply twice? Let me give you an example. Okay, let's do this. 13 times 98. I'm going to show you what the distributive property is really nice for. Okay, go ahead and do that mentally. Oh, sorry. Yeah, I'll give you time. Mentally. Yeah, I'm struggling right now. I'm like, where do I start? Okay, hold your answers because I'll give it to you guys in just a moment. Okay, how many of you, that's hard. It's hard for me. By the way, it is hard for me. It's hard. Okay, ready? Why don't I rewrite it? And I've showed you guys this, so this is not new. Ready? Why don't I write it 13 times 100 minus 2? Okay, you're like, wait. You can't just do that. Well, let's see. Is 98 also 100 minus 2? You just made the problem harder. Okay, do I have multiplication? Okay, oh man, if you guys get this, this is awesome. Do I have multiplication and addition?
Yes. Yes.
No.
Yes.
Okay, if someone says yes, please explain to your classmates how that's even, that's absurd, isn't it? Marshall? That's not addition, is it?
100 minus 2 is the same thing as 100 plus negative.
That's exactly right. It's 100 plus negative 2. And you're like, why would that matter? Okay, you don't have to change it that way, but this is what you do mentally. How many of you know what 13 times 100 is? Okay, I do too. It's 1,300. That's easy. I think, yeah, that's easy. How many know what 13 times 2 is?
36.
Close.
29.
Closer. If you can mix those answers together, you got it. 26. Do you see it? That was close. You're testing me like, Mr. Are you going to get that? Yeah, okay, yeah. Good. It's 26. What do you think I do with these two numbers? Just subtract them. So 1,300 minus 26 is 12.
I thought you said there was addition.
Yeah, it is. You could have said 100 plus negative 2, but you don't have to. You don't have to. Just keep it like that. Okay, sorry.
The answer is 1,274.
It's super close. It's
1,274.
super close. I'm super picky on some words. Go ahead. Try it again.
1,274.
Awesome. Very good. Didn't you say that? Do you guys get what I'm getting at there? All right, that's your answer. Is that pretty easy? I mean, is that easier? You're like, yeah, I guess it is because you told me it is. All right, do this one. 6 times 9 and the sixth. Mentally, sorry.
What?
Try it. Just try it mentally. And you don't have to get it right necessarily. I'll show you how to get it right next time. Okay, that's okay. Try something, get an estimate. Maybe you're close. I don't know. But I'll show you something here. I can't do that, by the way. I'm not doing changes to improper fraction, multiply, get those, multiply cross. Oh, man, I'm just lost. I'm lost. Unless. Okay, watch this. Ready? 9 plus 1/6. Is that true?
Oh, yeah.
By the way, guys, okay, ready? Aiden, I just called you out on saying the word and. Do you remember that? He was saying and. I'm like, no. He said and again, no. Then he didn't say it. Good. How do you read this number? 9 and 1/6. 9 and 1/6. That's what you're reading. That's accurate. Okay, ready? You're like, that doesn't even work. It doesn't help. What's 6 times 9? All right. What's 6 times 1/6?
136.
Somebody tell me which property is applied when you do 6 times 1/6. 6 times 1/6. It's one of those. What's 6 times 1/6? That's a property. And that's an easy property. Brian? Property. Yeah, inverse property of multiplication. What's 6 times 1/6? 1. So what's 54 plus 1? All right, guys. Close your eyes real quick. I'm going to give you a math fact. I want you to do it mentally. So you can write stuff down, finish it up. Okay, ready? Close your eyes. Don't look up. Close your eyes. Because I'm going to give you a mental math problem. You don't use your paper. You don't use your pencil. Just do it in your mind. Ready? Why do I see eyeballs still? I'm just kidding. All right. What is 6 times 9 1/6? What? Close your eyes. Close your eyes. Yeah, keep them closed. Keep them closed. Or I will give you a real problem. And you will do it.
What was the problem?
Yeah. 6 times 9 1/6. All right, I'm going to call on the person whose hand I see. I see Day. I see those hands. Yeah, I see him right there. Whoa, she's raising up even more. Okay, Day, what'd you get? Shh.
I got 55.
Whoa. All right, open up your eyes. That's impressive. Oh, my. Wait, oh my goodness, I do the same. How many of you get how to get that answer? You really do? All right, here's your real problem. And no paper. You can keep your eyes open, though. Where's my marker? Okay, we're going to go with... You can if you want. Yeah, that's fine. We'll go with 11 times 21. 11 times 21. Carry the 3. Par from the 7. Divide by 2. I got it. All right. I see Ben's hand moving across that spiral-bound notebook. Yes, what'd you get? Let me enter into the mind of Ben. This is what he thought. 11 times 20 plus 1. He did 11 times 20, which is what? 220. And 11 times 1. And then he added those two together and he got... And he got that answer. He did that so quick he didn't even know it. How many of you get 231? All right. Sorry, how many of you got that? Okay, keep your hands up. How many of you kind of did this in your head? Okay, a couple of you. Not all of you. A couple of you did it. Okay. How many of you did this in your head? Like this process didn't get it, though. That happens. Okay. Man, you're telling me after the 3rd time you don't know how to do it yet? Oh, I can't believe this. It only took Mr. A 100 times to do it. Is that a buzzer beater? Okay. Right here?
Yeah.
Yeah, what's 6 times 1/6? So that's the 1. So I did 6 times 9 and 6 times 1/6 and add them together. Got it. All right, guys, tomorrow, listen up before you leave. Tomorrow I will not be in here. I think what I'm going to have you do is do homework from these lessons. I don't know. Tomorrow you'll do homework from these lessons. Not today. Oh man, my plans are foiled.